In the previous lecture, we were solving this problem and we have exported the beam file. So now let's go to the file. So this is our folder. In this folder, you can see we have created beam1, beam2 HM file, and you can see beambending.inp file. So first let's expand this inp file. So make a right click. I'm going to open it with edit with Notepad++. Now I'm going to select the language. We can select any language according to our requirement. I'm going to select this band C. Okay, first what we can do is you can see these double stars. So double star is like a statement. So it means it does not take part in the analysis. This is basically a type of statement just like we do in the programming. So we can remove all the lines with these double stars. So for this, press Ctrl+F. In the find what, insert double star, go to mark. Click on bookmark line, click on bookmark all. You can see all the lines which have double star are bookmarked. Go to search and go to bookmark. Click on remove bookmarked line. We don't need them. Click. Now close. So you can see all the extra lines has been removed. Now Ctrl+S to save this file. So you can see in this INP file, the structure of INP file is like this. First one is the node. So this is the star node, and node 1, node 2 is the node ID, and again it is the node coordinate system 000 500 00. After that we have element. So element ID is 1 and element is created by node 1 and 2. It is type B31, element site is beam. So if you want to change anything, again we can change it also from the textpad file. This is much faster as compared to software because we can change the name or any property here and we can save it. After that we have beam section we have created, that is rectangular section here you can see, and these are the dimension here. The material is the steel. You can see the values. This is elastic like this. Then we have boundary. So boundary is created on the node 1. So it is node 1 showing 1 to 6. Then we have created a step. You can see the step here. We have a C load here. First one is a node 2. Second 2 is the direction and third one is the value. And here you will see output. So now in this output you can see the displacement is not showing. So for this what we can do is, okay, we don't need this field here because it is simple analysis. One more thing it has not shown is U value. So U comma. Why we have inserted U? Because we want to find out the displacement at the node. Sometimes it may happen due to the export or import. It does not show proper value. We need to once again go to Hypermesh and check it why it is not exported. So click on Ctrl S. So our INP file is ready. We can run it. Click on cancel. To run the INP file, we need a .cmd file. That is called the window command file. You can find this file in your search directory. So what you can do is click on this file, give it any name. I have given this name Z, right click, edit. Okay, so one thing we need to make sure there should be no space in the name of the file. Just copy the name of the file, beam bending, Ctrl C. Once again go to this notepad file, this Z file. Now here to run any analysis in Abaqus we need to insert some keywords. This is the keyword, call space Abaqus. Let me increase the size. Okay, now call Abaqus. Once again Abaqus J is the job equal to, insert the name of the file. This file name should be similar to this name, INP name. Then INT and then we can define the number of CPUs. CPUs equal to, let's say, 4. This CPU is optional for simple analysis. For complex we can define up to 8, 10, 12, etc. Again, there are many options to define the keyword. These are the simple words. Okay, so now call Abaqus j equal to beam.bending int CPU is equal to 4. Okay, it is okay. Now close it. What we have to do is just select the file, press enter, just run it. Now you can see the analysis is running. So it is showing some error. To find out the error, we need to open up this DAT file. Make a right click and open it with Notepad++. Once again go to language, select Bansi, and here we need to search for the keyword that is error. You can see error. One of the parameter field or history is required. Okay, you can see beam bending file. Here we need to define is the field. Select field here. Okay, so FIELD field. Now once again run this analysis. So Z, press enter. Now it is asking me to override, press on yes and enter. So when any analysis is running, you can see multiple files will be generated, and when the analysis will be completed, automatically all the files you can see will show like this. So once again open up DAT file, right click, add it with Notepad++. Here check whether the analysis has run properly or not. You can see one static analysis and it looks like run has been completed. Analysis has been completed. Also go to Ctrl+F. Here go to find, search for error keyword. If there is any error, it is going to show. You can see can't find. Close it. Now to find the result, we need to open up this ODB file. To open up this ODB file, before this you can also see the stat file. Stat file is basically the statistic file. Double click here. Okay, zoom out. You can see in the initial step 0.1% of the load is applied, that is time. 0.1, 0.2, 0.35, you can see at 1 analysis has been completed. If there is any error, it will show like analysis has not completed. Click on close. Now we need to open up this ODB file. We can open this ODB file in Hyperview, or we can also open up in Abaqus viewer. So I will go to Abaqus, click on new. Here go to visualization. Now copy the location here. Here copy this location, Ctrl C, and click on open. Type of output ODB, insert the location, select beam bending file and click on XY plane. Here click on the contour shape and here go to viewport annotation settings. Here go to legend, select fixed, apply. So it is now going to show the fixed values, and again the stress is now 75% average. I want 100% average. So result options, I don't want at the boundaries or anything. Make sure this is 100% and OK. Now I want to find out the displacement is, let's say I want to find out U2, that is in the Y direction. If you want both undeformed and deformed shape, click on this arrow, click on this third option. Hold down the left click and click on third option. This is deform and undeformed shape. Now if you want to open up this ODB in Hyperview, search for Hyperview and open up this Hyperview software. This is result viewer of Hypermesh. So here we need to click on load model. From here, load model, specify the location. This is now first in the load model we need to select the INP file. This is my INP file. Now in the load result we need to select the ODB file. Select ODB. Click on apply. And then let's say I will select XY. Then click on this option of contour. In the type I want displacement, magnitude, let's say magnitude. Section is component, click on apply. Right now you can see displacement is 0, 0, 0. It means our time step is not proper. So here in the step you can see it is now 0. So we need to select the last one. Increment at the time step 1. So make a right click here, go to edit legend. Here select fixed. OK. And you can see the displacement values. You can go to Y component, apply. Also if you want to find out the stresses, go to stress. I want the Mises stress and averaging is simple average. Click apply. And you can see the value of stresses here. So in this way you can perform analysis using Abaqus Hypermesh interface.